Right, welcome to tonight's lecture. In this lecture, we're going to discuss number system. Then apart from that, we further look at what rational and irrational numbers are. And my name is Hamted, by the way. Okay, so let's begin. Okay, so if you want to reach me, or if you want to contact me, if you have any questions, or you have anything that you want to tell me, or you want me to help you in anything, yeah. If you have any questions, any assignments, you can simply just contact me on any of these lines on the screen. Then we'll see how we're going to help each other. Okay, so let's first take a look at the types of numbers. So we have different types of numbers, some of which are even numbers. We have odd numbers, we have prime numbers, we have a lot of different types of numbers. Yeah, so I'm going to run through these numbers, these types of numbers, and then apart from that, I'll also introduce, I think, a new set of numbers which is not normally taught at high school. Yeah, so the first set of numbers we're going to look at even numbers. So we know even numbers are simply just numbers that are ending with either 0, 2, 4, 6, or 8. So you can also define even numbers as numbers that are divisible by 2, meaning where 2 can go in without leaving any remainder. Okay, we also have numbers that are called odd numbers. So what are odd numbers? So any integer, not really a fraction, that cannot be divided exactly by 2. That number is called an odd number. So the other way you can define an odd number is any number or any integer that ends with either 1, 3, 5, 7, 9 going up. So such numbers are called odd numbers. So examples of odd numbers are -3, you have 1, you have 7 going up. Yeah, so we have a lot of odd numbers. All right, so in case you have any questions as I'm teaching, feel free to interrupt and ask. You just need to unmute yourself and then ask the question. Okay, so we also look at another type of number, another set of numbers that are complex numbers. Yeah, so complex numbers are simply numbers that are in the form a plus bi. So this first part is called the real part. So this one is called the real part of a complex number. Then we have this other part, which is known as the imaginary part of the complex number. And then apart from that, the other thing I can explain on complex numbers is the I. So I'm sure you've seen I'm saying complex numbers are supposed to be in the format. Okay, let me do this. They are normally denoted by the letter Z. So if we say Z is a complex number, it's equal to, or we say let Z be equal to A plus BI. So we're going to discuss these complex numbers in details, I think, in the next chapter. Yeah, there are a lot of things that you need to know about complex numbers. There are a lot actually. But for now, let me just tell you what this I means. So I is simply just the square root of -1. So I'm sure at high school, whenever you say, or whenever you're asked to find the square root of -1, you are saying this is undefined. But in this case, we're going to be, wherever you find the square root of -1, we're going to be putting I. So once you put I, what is the square root of -1, then we call that number a complex number. Yeah, so that number moves from what is known as a real number to a complex number. So for instance, if they tell you to find the square root of -25, so the square root of -25 can also be written as the square root of -1 times 25, which can also be written as the square root of -1 times the square root of 25. So we know the square root of 25 is 5, and then the square root of -1 is equal to I. So the final answer will then be, so let me just write it here. So we know that the square root of -1 is simply just I, and then the square root of 25 is simply just 5. So when you multiply I and 5, you're getting 5I. Okay, so this is how you deal with complex numbers. Actually, there's a lot that you need to know about complex numbers. This is just an introduction. I'm introducing each set of numbers in brief. Yeah. All right, so we also look at prime numbers. So what are prime numbers? So prime numbers are simply just numbers with only two factors, 1 and itself. So prime numbers is simply just numbers with two factors, which is 1 and itself. Okay, so we know 2 is also a prime number because it only has two factors, 1 and itself. 3 is also a prime number because it only has two factors. 5 is 2, a prime number. Yeah, so these are some of the numbers that you need to know. So this is just an introduction of A-level mathematics. I always decide to start from the simplest things that people forget, because what I believe is that for you to solve a very complex or a very hard mathematical problem, you need first to know the basics. If you don't know the basics, or if you have forgotten the basics, it's very impossible. Yeah, it's almost impossible for you to solve any question in mathematics. So a lot of people ask how I managed to solve some questions. It's not that I'm intelligent or I know a lot of things. No, it's because of the basic principles of mathematics. Yeah, so once you know the basics, everything else becomes simple. That's why every time I'm explaining things, I always make sure that I start from the simplest things, then end at something that is a bit challenging. Okay, so we also have another set of numbers called natural numbers. So natural numbers are also known as positive integers. They are defined as the counting numbers starting from 1. Yeah, so natural numbers are simply just counting numbers starting from 1. So these are some of the examples. We have 1, 2, 3, 4, 5 going up. Okay, then we also have another set of numbers called the whole numbers. So this is a set of natural numbers, but to this set, we're just going to add a 0. So we know that natural numbers are simple numbers, are simple counting numbers starting from 1. So we go like that. But once we add a 0 in front of these natural numbers, the set changes now to a set of what? Whole numbers, and it's denoted by W, and natural numbers are denoted by letter N. Then we also have another set, which is the set of integers. So the set of integers is denoted by Z. Okay, so this is a set of whole numbers plus all negative, plus all the negative or positives, yeah, or opposites rather, okay, of natural numbers. Okay, so what this means is that integers are simply just a set of negative and positive whole numbers. This is the simplest definition. So when you get whole numbers, then you add the signs in front of these whole numbers starting from 0. Remember I said whole numbers are numbers, are counting numbers starting from 0. 1, 2, 3, 4, going up. So if we add negative numbers to these whole numbers, we form a set that is known as the set of integers. Okay, so we also have this very interesting set of numbers, which is the rational number. So rational numbers are simply just numbers that can be expressed in a fraction form, where the denominator is not equal to 0. So what do I mean? So any number that you can express in the form A over B, where B, which is the denominator, is not equal to 0, is known as a rational number. And in most cases, you have to make sure that the numerator there and the denominator are in their lowest forms, meaning there shouldn't be any number that can go into the numerator and the denominator, yeah, for this to qualify to be a rational number. Yeah, so it's as simple as that. So the definition I've just told you is one of the most important things that we're going to use or we're going to apply in this lecture slide when we begin to solve questions. So rational numbers are simply numbers that can be expressed in the form a over b. If you don't want to use a over b, you can use x over y. So rational numbers are numbers that can be expressed in this form where y is not supposed to be equal to 0. And then x and y are supposed to be co-prime factors. So what do I mean by co-prime factors? It means that the whole fraction is in its lowest term, meaning there's no number that can go into this fraction. Okay, so let's quickly move on. All right, so we also talk about the set of real numbers. So what are real numbers? So real numbers is just the summation of all the numbers that you can talk about, except complex numbers. So aside complex numbers, yeah. So aside complex numbers, we have another set which is called the set of real numbers. So any number that you can think of apart from complex numbers is a real number. So what does that mean? When we talked about rational numbers, we said these are numbers that can be expressed in the form a over b, but there are also numbers like the square root of 2, the square root of 3. These numbers, or pi, these numbers can't be expressed in the form a over b. What do we call such numbers? So such numbers are known as irrational numbers. So the opposite of rational numbers are irrational numbers. Yeah, so when you add the two sets, the set of rational numbers and the set of irrational numbers, when you put them together, the set that you always form is known as the set of real numbers. That's what it means. Yeah, so if you want, you can just say all the numbers in the world, you subtract the set of complex numbers, the remaining set is known as the set of real numbers. So we're talking about the set of real numbers. So the set of real numbers is simply just equal to the addition of rational numbers. When you add rational numbers and irrational numbers, the answer that you get is a set of what? Real numbers. All right, so let's quickly move on. Okay, so now let us look at the set of rational and the two sets, rational and irrational numbers in details. So this is where we're also going to have some of the calculations that I was talking about. All right, so under this same subtopic, we're going to discuss what rational numbers are and irrational numbers. Then we'll also prove the irrationality of 2. So you can have a question where they ask you to say, prove that the root of 2 is irrational. So how do you solve such a question? This is a question that a lot of people find difficulties to solve. They ask you to say, prove that the root of 5 is irrational. How do you know that the square root of 5 is irrational? So a lot of people find difficulties to solve such questions. They can also ask you to say, prove that 2 plus the root of 3 is irrational. How do you prove that? So these questions are simple and straightforward. So let us see how we're going to do, or how we're going to deal with such questions. And then we'll also look at repeating decimal numbers and repeating decimals. So repeating decimals fall under rational numbers. Yeah, so we have numbers that repeat. Let's say, for instance, we have 2.33333. So this is a repeating rational number. So we have what are known as terminating and non-terminating rational numbers. So any fraction, let's say for instance 1 over 2, when you divide 2 into 1, you get 0.5. This is a terminating rational number because it has an ending. But any number, let's say you have something like 1 over 3. This is a repeating rational number because you get something like 0.33333. These threes will continue repeating. Yeah, so that is exactly what I'm trying to talk about. So let us quickly move on to this other subtopic. Okay, so rational numbers, as I said, every rational number can be expressed in the form a over b, where a and b are members of what? Integers. And then b should never be equal to 0. And then a and b are co-prime factors. So it's very simple to, it's very important for you to know this. Sorry for the inconvenience. Okay, so this is what I was saying. Every rational number can be expressed in the form a over b, where a and b are members of integers. So a and b, meaning the numerator and the denominator, are supposed to be members of integers. Then apart from that, the denominator should never be equal to 0, should not be equal to 0. Then a and b are co-prime factors, meaning they are in their lowest term. So this slide, I'm going to send this slide to the group so that you can have a quick recap on what on the types of numbers that are, on the types of numbers. Yeah, so I'm going to send the slide to the group so that everyone can have it for study. Then apart from that, even the video will be sent to the group. Yeah, and those that have not yet made payments, you can simply do that as early as tomorrow if you can manage. All right. Okay, so let's quickly move on. And then, so I was just explaining what co-prime factors are. So co-prime factors are simply just, when we talk about co-prime factors, we say a fraction is in the form a over b, and then a and b are co-prime factors, meaning the whole fraction is in its lowest term, meaning there is no number that can go into this fraction. So examples of rational numbers are 1 over 2, 3 over 4, 7 over 2, negative 4 over 3. Okay, let's look at the types of rational numbers. So the types of rational numbers, we have integers. So integers are all rational numbers. Then fractions are all rational numbers. And we also have terminating and non-terminating rational numbers. So let me just briefly explain each of these. So one might ask, how is an integer, how is negative 2 a rational number? So if we say negative 2 is a rational number, we know to say every number can be written as negative 2 over 1, which means that this has become a fraction. Yeah, so this is a rational number. Remember we said a and b, any rational number should be, it can be expressed in the form a and b. And then all fractions are rational numbers. Then apart from that, we have terminating rational numbers. For instance, I gave an example of 1 over 2. This is 0.5. So this one is a rational number because it's terminating. It has terminated at some point. Then we have non-terminating rational numbers. So we have numbers like 1 over 3. This is an example that I gave, which is just the same as 0.5. 3, 3, 3, 3. So this is a non-terminating rational number. So it's a rational number because it can be expressed in the form 1 over 3, but it's non-terminating, hence it's a rational. Yeah, but it's non-terminating. Yeah. So let us see how we can rationalize a given terminating number, or rather a given repeating number, which is a non-terminating number, right? So we have this question here, which says convert the following decimal numbers to the form x over y in its lowest term. Okay, we have 0.545454. So 0.545454 can also be written as 0.54 bar. So this bound top simply symbolizes that 5 and 4 are repeating. So if we have a number like 0.235 and then there's just a bar of 5 alone there, means that 5 is the only number that is repeating. But in this case, we've seen that 5, 4 is repeating. We have two numbers that are repeating, hence the bar will be on two numbers. Right, so let's quickly see how we can convert this to a fraction. How can you convert this to a fraction? So you should pay particular attention. A lot of people miss the point on these questions. All right, so the first thing that you do, you say let this same repeating number that you've been given, you say let it be equal to a certain variable. So in this case, I'm going to say let x be equal to the same repeating number which I've been given, which is 0.54 bar. So this is what it's going to be. And then apart from that, so I mean the next step will then be us moving this point closer to the repeating numbers, but in this case it's already closer to the repeating numbers, hence there is no need for us to do that. So we move to the third step, which is moving this point to you move this point so that it covers all the repeating numbers. So let's move this point so that it covers the repeating numbers. So it's going to move how many steps? We're going to move 1, 2 for us to cover these repeating numbers. So this means that we're going to multiply the whole equation by 100. So if I multiply x times 100, I'm going to have 100x, then this will be equal to, when I multiply 0.54 by 100, I'm going to have 54 point. This 54 is repeating, hence it's still going to be there. So from there, I'm now just going to subtract this equation from this equation. So this is now just going to be 100x minus x is equal to, then we have 54.54 bar minus 0.54 bar. So 100x minus x, this will give me 99x. Then this side, when I subtract 54.54 bar minus 0.54 bar, this will then be equal to 0.54. Oh, sorry for that. So this will be equal to 54. So let me show you how to subtract that, because a lot of people tend to make mistakes. So if you are subtracting, say 54.54 minus 0.54. To subtract these two, you're going to have this minus that. So in other words, we just say everything that is repeating this side minus everything that is repeating this side, we get a 0. Then we have a point there. Then we have 4 minus 0, we get a 4. 5 minus 0, we get a 5. Hence, here we're just going to get 54. So we divide everything by 99, we divide everything by 99. Then we're going to get the value of x. So the value of x will then be equal to, was this and that cancel. Then here we reduce this to its lowest term. So we know that 3 can go into 54 and it can also go into 99. So hence 3 into 5, we're getting 1, 3 into 24, we're getting 8, and over 3 into 9, we're getting 3 into 9 is 3, and then 3 into this other 9, we're getting another 3. But we also know that 3 again can go into 18 and 3, so we can still reduce this. So we're going to reduce it. 3 into 18, that will give us a 6. 3 into 33, that will be 11. Hence, the final answer here is simply just 6 over 11. So this is a rational number. So sometimes they can't tell you to say express it in this format, but they are going to ask you to say show that 0.545454 repeating this side is a rational number. So how do you show it? You follow the same steps that I've done here. So let us do the next question. Then I'll ask some questions in case there is any. Okay, so let's move on to the next part. So B is so we say let x be equal to 3.61. We know that 3 is repeating, so we put a bar on 3. So first step, remember what I said? I said we move the point closer to the repeating numbers. So we have to move this point to that position there. So we move it, how many steps is it going to move? It's going to move 2 steps. So we multiply the whole equation by 100. So we have 100 times x, we're getting 100x. Then 100 times this, we're getting 361.3 bar. Then from there, we can now move this point to cover the set of repeating numbers. So for this point to cover a set, here we only have one number which is repeating, hence we're just going to move one point going this side. So that implies that we're going to multiply the whole equation by 10. So 10 times 100, we're getting 1000x. Then we say this is equal to 10 times 361.3 bar. This will give us 3613.3 bar. Because 3 bar will not disappear. Why? Because it's repeating. It's a repeating number. So from here, what we're just going to do is to subtract. So we're going to say this equation here. We're going to subtract this equation from this equation. So this would be 1000x minus 100x. Then we say this is equal to, then this side will do the same. So we say 3613.3 bar minus 361.3 bar. So we say 361.3 bar. So when we subtract here, we're going to have 900x. When we say 1000 minus 100, we're getting 900x. Then from there, we also have this other side. If we do the subtraction, we say, let me write it here. So we have 361.3 bar. Then we say minus 361.3 bar. When we subtract here, we're going to get the answer is, so this 3 bar minus this 3 bar, we're getting a 0 there. Then 3 minus 1, we're getting 2. Then 1 minus 6, we get a 1 from 6 there. So we say 11 minus 6, that is a 5. Then we have a 5 there. 5 minus 3, we get a 2. Then we have 3, 2, 52. Yeah, so we're getting 3252. So what we do now is we divide everything by 900. So yeah, so when you do the division there, so when you do the division there, you have to make sure that you reduce it to its lowest term as you divide. Yeah, so it has to be reduced to its lowest term. And one thing you have to understand is you will not be allowed to use calculators in this mathematics. Calculators are not allowed, hence you need to know how to do these simple calculations on your own. So when you divide everything there, you say x, this and that, you remain with x. And this side, we can find a number that can go in both 3,252 and 900. Yeah, so we can find a number that can go into both of these numbers, which I believe. So when you reduce this to its lowest term, you get something like a 271, and then the denominator of that. So you get 75 as the denominator there. Yeah. So do we have any questions on these two questions before we can proceed? Because there's an exercise at the end which you are going to be required to answer. Yeah, so I'm going to send the video to the group so that you can have it for revision in case when answering an exercise you get stuck somewhere. So there's an exercise at the end of this slide which I'll send to the group. So you have to answer it and then forward it to me on WhatsApp. Then I'll mark. Right, so let's quickly move on. So let's take a look at some of the rules of irrational numbers. So when you add two irrational numbers, the answer that you get is always an irrational number. So when you add two irrational numbers, the final answer that you get will be an irrational number. So let's say you get the root of 2 plus the root of 2. So the answer that you're going to get will be 2 root 2, which is still an irrational number. When you subtract two irrational numbers, the answer that you get will still be an irrational number. So when you do the subtraction, in most cases, the answer that you get is usually an irrational number. Yeah, so that's it. Then the other rule is that when you multiply and divide two irrational numbers, the result will either be an irrational number or a rational number. Then addition and subtraction of irrational numbers and rational numbers and irrational numbers result into an irrational number. So what that means is that if you add 2 plus the root of 2, this one is a rational number, this one is an irrational number. But when you add them or subtract these numbers, the answer that you get will still be irrational. Yeah, so that's what it means. Right, so this is just something that you needed to know. Then this is just an irrational number definition. So the definition of an irrational number is simply just the set of real numbers. So when you get the set of real numbers, remember what we said, the set of real numbers is simply just the set that is found by adding rational and irrational numbers. So when you get the set of real numbers and then you remove all the rational numbers, the numbers that you're going to remain with are called irrational. So in other words, the numbers that you remain with cannot be expressed in the form A over B. So they can't be expressed as fractions. Yeah, so such numbers are known as irrational numbers. Okay, so some of the examples are what you are seeing here on the screen. Then pi is also an irrational number. Okay, so let's see how we can find the irrationality of such. So they'll ask you to say, prove that the square root of 2 and the square root and 1 plus the square root of 2 are irrational numbers. So this link is ending in just 2 minutes. So what we are going to do is I'll end this meeting right now. Sending another link. Yeah, I'm going to send another link which you will be required to join. Yeah, so let's end here. I'm sending another link right now. You have to join so that we finish up the remaining part of the slide.